Oh, hi. Thank you for. So, good evening, everyone. You can open your camera. Okay. Welcome back to our class, plan 528. Okay. Uh, Today we'll discuss about um, financial analysis. So, I understand that some of you have learned about this, but some did not. So, I'm trying to present it so that any one of you may get some insight. Okay, so it's about more of probably more of financial education. Okay, rather than just technical analysis. Okay, okay. So you can get the slide in Moodle. I think there are more than 100 slides there. Okay, in that particular financial analysis slide. Okay. Yeah. Okay. So let's start that. I hope you can see my screen. Can you see my screen? The financial analysis. Okay, good. So we'll talk about the time value of money and the effect of on interest and system computation. So talk about the equivalence, okay, and equilibrium, okay, of money. Okay, so by the end of this lesson, you should be able to comprehend the effect of compound interest, okay, uh, including the time, and then you should be able to compute the present value, future value, and annuity. Okay, so that is a very simple objective. So, wait, uh, first, how much is your income? Okay, no need to mention, you just put in your mind. Okay, and how many hours do you work for your income? Say in 1 month, say you get certain amount. Then uh, next question is, now if you put your money in the bank, okay, you're supposed to get an interest, isn't it? Okay, so I want to know how much is the interest per annum, per year? Tell me. How much is the interest? Yes. Um, Now, at the same time, if you borrow some money from the bank or from money lender, you pay interest. Eh? If you put your money in the bank, you gain interest. But if you borrow, you pay interest. So question again the same. How much is the interest per annum if you borrow? Or you don't know, or you pretend to know? Okay. In that case, can you find the information in the internet. You have internet, isn't it? Okay, so go to your Google
For
and
I
yeah,
uh
yes,
I'm I'm looking at bank from BPI
okay.
for interest rate per annum is 0.0925.
Wow, 0.0925.
925
That is interest of saving.
saving.
Okay. Percent.
Yes.
Okay. And if you borrow,
If you borrow, wait, sir. Where do I? Um, if you borrow, wait. So, it depends on the amount on how much you.
okay, so more or less, I just want to get the range.
Okay, sorry. Monthly add-on rate, it
Yearly.
yearly. Wait, sir.
Uh-huh.
Yearly.
Did you ever borrow from Pak Ipik or something like that?
I don't know if it's correct. It's mahal. 14.4
Okay, 14.4% per
yeah,
year.
per year.
Okay, so if you borrow, okay, about 14.4 now, and then if you save, you only get less than 1% practically. That's very unfair now. The bank getting too much, more than 14%. Okay, so uh, now if you work, okay, do you get an increase in salary per year? How many percent on average? Anyone want to answer that? Hmm? If you work, only increase in the workload. So you don't get the increase in salary per year.
Sir, if you work in government, sir, they are required,
Okay.
sir, yearly.
Ah,
But in private, not really.
okay. So tell me, what is the increase of salary in the government? More or less is okay. No need to get the exact amount. So just the range.
I use, sir, just assuming
Okay.
assuming 1,000 increment per year. I mean 1,000 increase every year. So it would take at least 0.038%. So
Percent.
I no, sir. It's 3.84. Sorry,
Okay.
3.8.
3.8
Yes.
percent increase of salary. How about the next question is crucial. How about the inflation rate? Just search in Google. You have internet connection, so just the formal one is okay.
Inflation rate right now is around 3 to 6% for this,
Three to
I think.
between 3 to 6%.
Yes,
3.4.
3.4.
3 point. Okay, so 3.4% formally inflation. Okay, so if you increase your salary by 3.8, that means you are still have an increase a little bit. So almost the same increase. But if you are working in private, some of you said I did not get any increase. That means you are shouldering the inflation. Is that correct? So over time, you become poorer even if you work. Okay, so okay, let me continue a little bit so that you can start to see. Okay, so suppose now, so let's start with the mathematics now. So suppose in June 1, okay, I deliberately did not make January 1. So okay, suppose in June 1, 2020, you start a saving account of 1,000 pesos. Okay, let's assume hypothetically, so there is no bank fee. Okay, there is not even the tax. Okay, so say suppose the bank pay in 10% interest in its account on annually. I know it's impossible in the Philippines, but for the sake of discussion only. Okay. Question is, can you make the mathematical formula for that saving account? And how much is your money, okay, in that saving account by June 1, 2032 in what's 12 years? Okay, so 12 years, what will happen? So in this case, let's make a discrete time. Okay, so the way to do is, because we put the same date, okay, so June 1, 2020 will be time 0, right? And then June 1, 2021, that will be time 1. Okay, June 1, 2022, that will be time 2, and so on, right? So any other days is not relevant, okay? Only June 1, because every year we are computing. So June 1, 2032 will be time 12. Is that okay with this? Instead of the actual date, okay, we just make it discrete, no? 0, 1, 2, 3, and so on, so that easier to compute. Okay. Next. So your initial amount, I will put that as A0, which is 1,000. Okay. Right. This is the amount in pesos. So in A0 means the amount of your money in pesos, yeah? At time 0. It is June 1, 2020. Okay. And in the first year, if you get 10%, okay, this is supposed to be your money, isn't it? So 1,000 plus 100, 10% of that 1,000. So you get 1,100. And then in the second year, because this is compound interest, okay, so you don't get it from the zero, A0, but you get it from the first year. So you use the same formula here. A2 equal to A1 plus 0.1 of A1. Right? So that A1 is already computed, so 1,100. Okay, and then 0.1 times 1,100, so you get 110. So you get now, in the second year, you get 1210. Right? So if you compute it this way, eventually you will get 3,132 in the 12 years. So your initial money is only 1,000, okay? But because of the interest and keep compounding, so your money worth in 12 years become 3,100 plus. Okay, so then we will say, okay, in that case, this is our first mathematical formula about the money. So we can put that A, K plus 1, K is either 1, 0, 1, 2, 3, and so on, is the same as AK. This is the subscript. And then plus 10% a while ago, because this is the interest of that AK, isn't it? right? So meaning the amount in our account next year is exactly the amount of our account this year plus the interest, yeah, amount of this year. Well, of course, it's tedious and time consuming if you compute this by hand. Okay, so then we have other solution. Okay, other solution is to compute by substitution. Okay, so initially you have A0, this is your 1000. Okay, and then we apply the same formula. Yeah? So A1 equal to A0 plus 10% of A0. Okay, A2 is equal to A1 plus 10% of A1. Isn't that the formula a while ago? But we can put back A1 is already computed. So then we can put here. Everything become A0 and then you simplify. Yeah? You simplify, become 1.1 exponent 2 times x0 and so on. So if you do the same simplification, okay, eventually you will get this formula that a k plus 1 equal to 1.1 exponent. This one, when it is 4, this is exactly the same. So k plus 1 times a0. Is this too much for you or is it okay? This is just the derivation. Okay. The point is now you can get this formula of any k, okay, any year. Okay. So the next question is how if the interest rate is not 10%? Okay. Say the interest rate is I%. Okay. So 100 times I%. So when we put I is 0.1, that means interest is 10%, right? So in that case, you can write, okay, in this general formula of saving account, A of n plus 1 equal to an plus I, the interest of an. Okay, a while ago we used exactly the same. You look at this. So I is in here 0.1, 10%. Okay, now we just make it general. So instead of 0.1, now become I. Okay, so and then a while ago we said, okay, this is the formula of the final result. Okay, ak plus 1 equal to 1.1 exponent k plus 1, a0. This is exactly that we use here. So instead of ak plus 1, I put ak. So then this is the formula. Okay, this is the actual formula that we use. So I'm just telling, look, this is the derivation of the one that you use. So this is called difference equation. Okay, so what is difference equation anyway? So difference equation, okay, is an equation that describes the relationship between state variables in one point of time with the previous point of time. In other words, difference equation is actually an equation involve the difference. Okay, so in mathematics we symbolize different equation as this. Yeah? So you have a y k plus 1. This is the time. K is the time. Okay, it's a function of yk minus 1, and so on. Okay, so because we can, this is k plus 1 and this is yk, so we can put this part on the right hand side, something like this. So that means you have a difference. So the difference is a function of another function g here of the same thing. Okay, so this is what is called difference equation. So any mathematical financial formula that we are doing actually come from here. So this is the main basic form. Okay, so if you learn about this, then you can solve anything more than the financial. So the solution of the difference equation Okay, it's again an expression or formula that makes the difference equation true for all the values of integer variable k a while ago. That is the time, and does not involve any difference. So we just did the solution by computing this recursively, right? Uh, let's say we have this what is called affine difference equation. Okay, yk plus 1 equal to a yk plus b. So this is next year. This is this year. Yk is this year. A and b are constant. Okay, and you know the initial value y0. So how to solve this? Simple, yeah. So first, in the first year, or the k equals 0, that is the initial value, you have y0 equal to small y0 here. Okay, this is given, right? And then our formula a while ago is this one, right? Yk plus 1 equal to a times yk plus b. So in that case, y1, okay, is equal to a times y0 plus b. But this y0, we already know the value. Okay, so then we can put it here. Okay, how about at time 2? At time 2, the same formula again. Okay, so this is 2, then this is 1, right? Just 1 before. So in that case, now y1 is already given here. Then we input here, okay, and then we simplify, and so on. Okay. Eventually, you will see this is the at k4. Okay, we will see two terms here. The first term is a exponent 4 y0. The second term is a series. Okay, and this series is actually a geometric series. So if k equal n, okay, you will have exactly this. So you will have this geometric series of this, and this geometric series have a closed form result, which is equal to n. If a is equal to 1, and equal to this exponent equation, okay, if a is not equal to 1. So this is very general solution. Okay, so for any affine, okay, difference equation like this, then these are the solution. Okay, so you just keep this in your note. Okay, you get the solution of any affine difference equation. Okay. Okay. Before I proceed further, is there any question about this? Is this too much mathematics for you? No. Okay. Thank you. Yeah. Okay. So let's come back to financial. Okay. Say, suppose again, you set aside your money, okay, 1,000 pesos per month for your retirement. Per month, 1,000 pesos, okay? And then you put your money in the bank since 17 years old until you retire at 65, okay? So let's simulate this, okay? So assume there is no bank fee and no tax, okay? So the interest rate is also constant, say 1% per year. Question is, how much is your retirement money? If you save every month 1,000, Okay, from 17 until 65 with interest rate of 1%. Okay, how much is your return on money? And then next question is, what if you start not 25 years old, not 17, but you start later with this 25 years old, or you start a little bit later with this 40 years old? And then, okay, the next question is, what if instead of 1% per year interest rate, what is the interest rate is actually 10%? Okay, you can assume the annuity computed for payment at the beginning of the year. Okay, so three scenario: saving no interest, 1% interest, 10% interest, and then for each you have three scenario. Start at 17 years old, 25 years old, 40 years old. Should have 9 answers. The formula is already given a while ago. Can you try to compute? Uh, the simplest formula, usually we write it like this, right? So P, okay, plus I, okay, times P, okay, equal to F. Okay, this is in 1 year. So if you want to put it in any years, okay, then you compute by, yeah, I will clean this one. Please. So put it in N. So your future at times K equal to your P 1 plus I exponent K. Is that correct? P is your present time. Okay. So I is your interest. So anyone want to show your computation? Well, the formula is easy. You can get it. And so try to compute first. Can I stop sharing? Maybe you need some time. Yeah, Angelo, you want to say something?
I guess, sir. Let me share my screen.
Okay.
Please allow me to share my screen.
Oh, sorry. To make you host. Okay, anyone?
I'm
Okay, you can.
So for interest rates of
1%. Okay.
and then From 17 years old to 65 years old, your future
Mm-hmm.
would be 1,612.20.
Oh, wait. Oh, you are saving per month.
Per month.
Hmm. Every month you put aside your
Ah,
1,000.
ah. So this would be times 12.
I think you need, sorry, I think you need to compute. The formula probably you need to use
Oh,
annuity.
I think so. The formula there should be
Annuity.
yeah, there should be a parenthesis for the one plus C2 raised to D2.
Hmm.
hmm.
I think it should not be an exponent, sir.
Good.
It should be an exponent.
For the 0%. I mean
It's
the
the same.
Times the exponent to 12. Multiply the exponent to 12 so that it will become per year.
No.
No? Okay.
No.
Sir, is the interest rate per month or is it per year?
Per year. The interest rate is per year. So if
Okay.
your money is per month, so
Ah, I get. Sorry.
that means say you put aside per year, that means 12,000 per year. That
Yes, sir. 12,000 plus times 1 plus the interest rate to the
okay.
power of the number of years.
Okay.
Uh,
48.
this would be the results, sir.
Hmm. Okay. Let me check my slide.
sir, can I share my calculus, sir?
Sure. Ben. Um, you are co-host already. Why so little? Right? Uh, can you see his screen? I cannot see.
It's still loading on my end, sir.
Okay.
Hello, sir. Can you
Okay.
see it now, sir?
Okay. Oh, 500. This is correct. What correct?
Can you see the calculator, sir?
Yes.
Sir, for the first case, the no bank fee, sir, I assume it's
Mm-hmm.
a simple interest formula only, sir. So there should
Correct.
be no exponent, sir. So the typical formula for simple interest is P times 1 plus RT, sir. No
Mm-hmm.
exponent. So as you can see with my calculation, sir, since the interest rate is per year, I divided the 1% divided by 12,
Okay, by
which is
12.
that will be
Correct.
the R, the
Correct.
interest rate per month. Then I
Mm-hmm.
will multiply that to the T, which is the period,
Mm-hmm.
12 times 65 minus the 17 years old, which is yung 48 po, which is the 48 years
Okay.
that Sir Angelo showed a while ago. So I will
Yeah.
arrive with the value of 576,480. Around
Okay.
that value, sir.
Around that value. Okay. Super. Thank you.
Thank you, sir.
Super. Yes. So let's say I put there in the screen. So if you have no interest, right? If you have no interest, so you have 65 minus 17, okay? And then you multiply by 12 months. So you have 576 months, correct? That means if you start from 17 years old without interest, okay? So that means 576 multiplied by every month 1,000. So you're supposed to get this. Okay. And if you start at 25 years old, you have only 480 months. Okay, so this is your money. Okay. And if you start at 40, you have only 300 months. So in that case, you get only 300,000 pesos without interest. So up to here is okay, right? So now when you have your interest, say at 1%, okay, so the interest rate is 1%, so 0.01, okay, then you have divide by 12, right? Because this is supposed to be per annum. So in this case, very small per, and then you use this K, yeah, is 576. So you get a little bit bigger, okay, 700 something. Okay, and here become 500,000, and here become, instead of 300, now become 340. Okay, and next we simulate, okay, what happened if our saving at 10%? Look at the number. Okay, the same computation, yeah. So instead of 0.01, okay, the interest rate now become 0.1 here. This is the only difference. Okay, and now you have 40 million money. Okay, and 6 million if you start 25 years old, and then if you start 40 years old, you get only 1.3 million. Okay, so with that, okay, let's compare without interest, with 1% interest, and 10% interest. So, what do you think? Which one is have more influence? Time or the interest or the amount that you save? Huh? You want to say something, Avi? Can you unmute? Yeah.
Time and both time and interest.
Time and interest. What happened if you have only instead of 1,000, okay, you save 10,000 a month?
All the values here will be multiplied by 10, sir.
Yeah, exactly. Only multiply by 10, exactly the same as your amount. But time will help you a lot.
Yes.
And then the interest rate also help you a lot.
Actually, sir,
In
equal affects, sir.
equal to exam. Very good. Okay. Right. So this is formula is easy. You can just get the formula. But the point is, if you can start to see the meaning behind that formula, the value, okay, which one is more sensitive, okay, is actually the time and the interest. Okay. Next is about inflation. Okay, what is inflation? Inflation is the measure of decline in the purchasing power of our currency. Okay. For example, price of food, okay, over time getting higher. Okay. And the government usually only put small, okay, market basket commodity, for example, oil, rice, water, electricity, salt, sugar, and so on. So they check they monitor only the commodity, okay, that is maybe they thought this is the most important, but many other things they did not compute, okay, for the inflation. Now you already checked a while ago, okay, the inflation rate is at 3.4. Is that true or not? Question is, can you check the cost of the food and the transportation a few years ago? Okay, and then compare it to now. Okay, how much is actually increased and over how many years? Anyone still remember?
I remember jeepney
Okay,
is 4 pesos,
4
and
pesos.
the minimum fare is 4 pesos.
Okay,
And now it's, I think, 12
12.
or
Okay.
13.
When was that? Okay. So when was that?
4 pesos, 2000. Anong years? Wait, sir. 2000, I think, 5.
2004.
2005? 4,
20
yeah.
years ago.
Okay, 2005 and now is 2024. Okay, so from there you can calculate the actual inflation in terms of transportation. Okay, the same as your food. Okay, so later we can practice that. Yeah. So the same thing. Yeah. How much actually you earn per year, right? And then at what rate your earning is increased per year, and uh, at what rate of increase can you cope with that inflation or not? This is crucial, right? Because if your rate of increase in the earning does not cope with the inflation, that means over time your quality of life reduce. If the same as inflation, that means you are just keeping exactly the same. Okay, so any discussion about this? Or you don't concern at all?
Sir, here in the Philippines, only the inflation increases, not the salary. Golden era pa more.
Really?
Yes, sir.
Only the inflation increase, but salary not increase.
Not really, sir. So they
That
are
means
the
over
current.
years you get poorer.
Yes, sir. Only the debt is increasing.
Oh no. That's very sad. And how about the house? The property price? How much they increase per year? So if the house price increase like 5%, 10% per year, that's considered inflation, right? That's mean the gap between, because you did not increase your salary, that means the gap between your income to the price of the house is getting larger and larger over time. Is that correct? So over year, even if you work very hard, your quality of life reduce, not increase. If that is the case. Okay. Anyone want to say something? Government worker, they have salary increase. Okay. So it's not required for the private to increase. Yeah, Junafi.
Hello, sir. Good evening. For like
government workers, it's actually like mandatory to increase their salary, but it's only at a minimum. Like for example, teachers have like 100 pesos increase every year, and but there's also a difference if you're a casual employee in government work and job order. They don't increase unless the government or the DBM, Department of Budget and Management, have like a policy for the increase in the salary. They will increase it. It's the prerogative of the government offices, but at the same time for private sector, if I'm not mistaken, they can follow the minimum wage.
Income.
Yeah. So it depends on, I think, the company for private sectors.
I see. Okay, thank you. So, is there any other comment or opinion about this matter?
Sir,
Yes, Angelo.
so we've talked about loans a while ago. I just realized that big companies loan to banks so that they'll have capital, and then
Okay,
they get their income or returns from it, and then they pay the banks. So they practically don't spend they practically spend zero money in building their businesses, while our money, which we deposited on the bank, gets lower and lower value, and then
mhm,
so the richer gets richer and the poorer gets poorer. That's
okay,
my point.
okay. So, okay, not in the slide. I would like to ask you this. Suppose you want to open a business, okay? And at what rate of your business growth you are going to borrow money from the bank? Say, for example, the bank interest you said a while ago is 14.4. Is that correct? Abi, you are the one who said that. I recall it. So 14.4% per annum. Okay. So if your business only produce 10% per annum, will you borrow from the bank? I don't think so. Correct? So your business should earn higher than 14.4, which is the bank interest. Say, if your business can earn 30%, okay, that means you give the 14.4%, let's say make it 15 now, so that is okay, 15% to the bank. So the remaining 15% is for your own business, isn't it? Okay. Logic, yeah. So you don't borrow from the bank, okay, when you are expecting your business growth is actually lower than the bank rate. Okay. Yes, you are telling that, oh, that the business can borrow from the bank without that money, they can build, but there is some limitation even with that, isn't it? Hmm? So, uh, meaning your business should earn more than the bank rate. Okay. Otherwise, of course, you will not survive. Okay. So the risk is the problem there. Okay. So let's put this next slide is about the home loan. Okay. So I want you to uh, through this simple practice, no? uh, I hope you can get the understanding. Okay. Suppose you just bought a house. Okay. So after paying down the payment, so the down payment, okay, the remaining balance is 1 million pesos. Okay. And you have cash. Okay. But there is an offer that you can take loan from the bank. Okay. So here is the options, okay, that you have. Okay. So 5 year, 10 years, 15 years loan, at 10% compound interest annually from the bank, or you can borrow cash from your uncle. Your rich uncle will give you cash, but flat, not compound annually. Okay, just 30% interest. Okay, again, you can offer 5, 10, or 15 years. So which one is your decision? Okay, so the clue is simple. Okay, how much is your monthly payment for each option, right? And then which is better for you, actually, the flat rate or the compound? Okay. Of course, you need to compute. Okay, take some time to compute. I want to see. Is this something interest you? So Excel, I computed this way. So your home loan is 1 million pesos, right? So interest rate is annually 0.1, and then the interest rate for flat is 30%. So I have 5 years, 10 years, 15 years. And if we compute the monthly payment, that means the principal plus the interest. Or which one is the smaller? So compared to flat and annually, apparently in this case, the flat is still smaller, isn't it? If you compare the row 9 and row 10 here, okay, the flat is actually smaller. So you're not necessarily, okay, what you see as 10% interest and compared to 30% interest look like a very big number, 3 times, but this is flat and the other one is compound interest. So in that case, you better check. Okay? You better check the detail with a simple computation like this, so that you will know your decision. Okay. Anyone want to share your screen? I'll make you co-host so that you can share your screen. Were you able to get those values? The formula is using annuity. Okay, so this one. At the bottom here, this is the formula. So A is the annuity, meaning the amount of money that you're supposed to pay. B is the initial loan. K is your interest. N is the time. Okay, number of years in this case. I think I make this in Excel, so you can make it on your own also. I think this is quite interesting. Why this is interesting? You can start to see the non-linearity of time. Yeah. This is N is the time. Each row, so is the time. See up to 30 years here. And then K here is the interest rate. So the one in blue that I put here represent the, say for example, if I use 10 years, this is the amount of money that I need to pay monthly, every month. Okay. Say for example, if I have 10% interest and then for 10 years, that means I need to pay per month 13,000, right? And from here, you can start to see if I have only 1 year to pay for 1 million pesos, that means I need to pay this much per month. The expense. And look like the time matters also. For example, if you put it 30 years, okay, you pay very small amount, see, okay, compared to 10 years, okay, but you need to pay very long time, right, monthly. And of course, the higher the interest rate, okay, it jump almost double. Can you see? If I have no zero interest, okay, no interest at all, so I need to pay 8,000 per month. Okay. With 15% interest, I need to pay double. It is 16,000 a month. That means the interest alone is already eating up my loan double. Yeah. But for 10 years, that one double. But imagine if for 30 years, you are paying, look like, if you don't pay any interest, you're supposed to pay only 2,700 pesos per month. with 15% interest, you're supposed to pay 12,600 per month. Wow, how many times compare this one? 2,700 to 12,000. Okay, that means most of your money is not to pay the principal. No? Your principal is 2,700 here, right? But most of your money is to pay the interest, which is like 3,000. So 4 times. No? So 3 out of 4 is actually you're paying the interest. Have you ever realized? So this is, I just put here is only up to 15%, isn't it? So I put here, be careful with the um, sharp, loan sharp, yeah? Yeah, including the uh, credit card, okay, Visa, MasterCard, and so on. So if you get the credit card and you did not pay, how much is actually your interest in the credit card? Anyone experience? You don't use credit card? Anyone? Really? Nobody is using credit card in this class? So if you are using credit card, okay, usually around 3 to 3.5% per month. Yeah. Credit card interest is 3.5 per month. That means, say, simplified, you multiply by 12, that means around 36 to 40% per year. That is how crazy the compound interest of credit card. Okay, so this table, I use this formula. You can try on your own. Okay, so the P here I put 1 so that we can see the effect of compound interest and time. Okay, so K is the interest, N is the time. So the time I put from 0 to 30, and then the interest again from 0 to 36. Yeah, 36 is like the credit card interest or the loan sharp interest. And say, so that you can see clearly. Okay, so I put 10 years here and then 10% here as a blue. Okay, so if you borrow without interest, without time, that means you will get 1. Okay, so if you see here, the first column is all 1. That means if you borrow 1, you will return 1 because the compound interest is 0. Okay, so but if you borrow 1 in 10 years and in at 10% interest, you need to pay 2.59. What does it mean? That means what you borrow is only 1, but you need to pay 2.59. So that means almost 2.6. Nah? So 1.6 is for the interest, 1 is for the principals. Meaning your interest is more than the principals already. So you are thinking, oh, I only pay 10% interest. Your thinking is still linear. This formula is non-linear, dear. Okay? you are thinking in linear term, 10%, and then you are thinking in 1 year only. Right? Yes, in 1 year, correct. That one you get 1.10, you see. But if you put it in 10 years, okay, you need to pay 2 times. If you borrow for the home for 30 years, you borrow only one, you need to pay 17 times. Okay? That means crazy. Okay? Look like, oh, look here, this is exact value. I pay only 8,000. No, when you pay 8,000 per month, actually you are giving the bank 16 times of your money. That's why you're getting poor. Do you realize? Okay. From this value alone, you can start to see, even if at 10% interest, so you are paying at 30 years, you are paying actually 17 times of your loan. Your loan is 1 in here. You see, P is 1, but you are paying actually 17.45. So how, I hope this open the some insight to about the meaning of loan and compound interest, because sometimes you don't understand that this is non-linear. Okay, you thought it is only double or maybe just 10%, meaning maybe just little, but no, it's actually up to something. And if you are 36 percent, like the loan shark or the Visa Mastercard, you see here at 30 years, you get 10,000 times of one. This is almost impossible for you to pay. Okay. In the next practice, I want you to, maybe the next practice, some of you may shock. Okay. But let's
Uh,
see the, yes, go,
so,
go.
sorry, sir. I can't seem to get the answer for the annually.
Eh? To annually?
Yeah,
Oh,
can I share
this
my
one?
screen?
Oh,
Yes.
sure.
Where's my screen? Wait, sir. One more. This for wait.
The home. The loan is 1 million,
Here for
and then
um
the, okay, so that one you can use A equal P and then multiply by that formula. The next slide, formula.
uh
Copy.
sorry, sir.
The next slide, formula.
Ah, wait, sir. Ah, wait, wait, sir. Oh, okay, sir. Wait. I'll get back to you later, sir. I'll check first.
Okay. Or maybe if you want to get the all the formulas, I think there is already there. Almost the end of the slide. Okay, I think in page 90 and 95, you get all the formulas there. Okay, let me share with you. So this is the, can you see? So this is the formula to convert. Okay, so if you have, go to the slide page 94 and 95. Okay, so I have how many? 6 formula here. So P mean the present times, K mean the interest, N is the time. Okay. F mean the future. A is the annuity. Okay, that's simple. Okay. And if you know the present times and the K is the interest and the time, then you want to find the future. This is the formula. Okay. Of course, you don't like to use the formula. You can use Excel function. So this is exactly the Excel function of this formula. So you put the K, N, and then put 0 here, then you get the P. So the earlier for AB, you can use the this one. Use minus PMT, okay, of K, N, and P. This is the formula. Okay, and then next, you can get F from A from F. Okay, again, this is the equivalent Excel function for this formula. So what's the difference between 1 and 2 is noted here. Okay, it's just the payment is in the beginning of the year or the payment at the end of the year. Okay, so I put note here also number 3 in Excel function that Excel will automatically put negative value for the loan. So thus to make it positive, we need to put negative in the beginning of the formula. So here I put negative here, okay, in each formula because this is basically loan. I hope with this formula you can use. It's just simple calculator. So for earlier, you want to get A, isn't it? From P. So this is the formula that you use. Minus PMT, K, and P. Yeah. Okay. Anyone want to show your screen? So any comments? Probably. Any opinion? So with this, I hope you realize the power of interest rate and time. Okay. So it can go against you, but it can also go empower you. This is just tool. So at the same time, okay.
Sir, I have a question.
Go, Christine. Yeah.
Because I vaguely remember that some banks, some Muslim banks don't charge interest or something like that.
Correct. That's
So how
correct.
do they make money? Because I'm
Fee.
just so used to the Philippines system.
Right. So there is a fee. They make fee because for the Muslim interest is based on the Old Testament, also in Christianity. Okay, they don't allow interest. This is kind of sin based on the religion. So in that case, flat zero interest, but they have fee, bank fee. So if you put there, you need to pay the fee, which is actually the same as interest anyway. but it's flat. Okay, so only the way to compute is different, but at the same time, there's fee that you need to pay to make the bank survive. Yeah, it's
Thank
good
you.
question. So yeah, in Indonesia, even though we have a special bank for that kind of no interest, okay, we have also the normal bank with the interest. So both sides can survive. Okay. In the international community, of course, this kind of computation is the common way. So more look like the Philippines setting. Okay, the only difference is probably your interest rate is totally too small. Okay, now, for your information. So if you do business, how much is supposed to be your interest? I mean the growth. At bank rate of 15%. Okay, so your business should be around more than 15%. No? Normally around 30% growth. Okay, otherwise you cannot survive your business. The same thing, I think 14% is too high. So if you have inflation of 5%, 3 to 5%, that means to put against inflation, you need to have a way so that your money will grow at least the same as the inflation. Otherwise, you are in trouble. Correct? Okay. So if you put in the mutual fund, okay, search now, mutual fund of the Philippines or the bond, government bond. Okay. How much is the interest of government bond in the Philippines? Bond, you know, do you understand the meaning of bond? Meaning the government put loan to the people.
It's 4 to 5%, sir.
Oh, very good. Now you know it. Okay, so it's better than inflation, isn't it? So that means if you have money, okay, you at minimum you need to put there. That's the protection against inflation at the minimum. Clear, yeah? So how about the stocks and mutual fund there? Can you search? You have Google, you have the power of a search engine.
Uh, Stocks doesn't generally have interest rates, or
Oh,
it
the
it
stock have
it
two possible things. Now, one is the dividends. The second is the capital gain, not the interest
mm.
rate. You can
Okay,
say,
okay. But still, sir, the dividend is depending on the company when will they release.
no problem. So, for example, TEL,
Okay,
PLDT,
so
how
sir,
much is
we'll search for. Thank you.
okay? So the blue chips or Globe, for example. So you can just check there. Okay, Jollibee, right? So you can check there, and then how much is the dividends per year? Normally they give, and then the same thing. How much is the capital gain? Okay, or the stock price change? Of course, it's fluctuated over time. You can start to see. Okay. So normally about uh, the same as the government loan a while ago, between 10 to
Uh,
15%.
It says here, one company offered 7.29 annual dividend yield.
What company is that?
That's PLDT, Philippine Long Distance Telecommunication
Yeah,
Company.
PLDT tel. Okay, so that's 7 point something.
7.29
Okay,
annual
so
dividend yield.
dividend,
Yes, po.
dividend
Yes, po.
only then. Okay,
Yes, sir.
so that means if you keep your money saving in that, buying that kind of stocks, okay, if that stock, I mean, if that company will not be uh, bankrupt, okay, will not become bankrupt. So the possibility is you can get around 7.20 something percent. So when I talk about 10% interest, that means that is not impossible, isn't it? Okay. Earlier, when you just look at the bank rate saving, which is less than 1%, you are telling, ah, this is like nothing. Yes, but you don't put your money in the bank and then for saving, that is a kind of, you are giving your money to the bank, isn't it? Of course, you will not do that, right? So you start to choose your own financial term wisely. So I know we are talking about this for public sector, okay, which is for transportation project and so on. But at the same time, if you cannot manage your own personal things, how can you manage public money? Okay, so first of all, you need to know how to manage your own personal things, finance. Okay, with that, when then when you are interested with a much larger amount of money, which is public money, then of course you can make it bigger. Okay, so number one is you need to know how to manage your own personal finance. Okay. So I hope this is eye-opening, okay, about the possibilities. Okay. Of course, each of these option have risks. Okay, so later we can discuss more detail about that. Okay, but at this point of time, we just want to get the financial analysis done right first. Okay, I know you know the formula. Okay, the formula is not secret. Like that six formula a while ago is not secret. So it's anywhere you can get from the books and so on. But from the lecture, I hope give you some insight. Okay. Okay. So next insight is I hope this is more powerful. Okay. Okay. If you want to have, say for example, yeah, your bank pay 8% interest, compound quarterly. At this point, instead of monthly, okay, we compute quarterly. And then your initial deposit is just 100 pesos. Okay. So let Y is the amount of your account after K quarter. Okay. What is the uh, formula to get this? And then uh, can you compute the amount of our account at the end of 1 year? So 1 year is 4 quarters. Okay. And what is the formula for all of this? Okay. So back to the difference equation earlier. Okay. So in this case, you have 8%, so 1.08 of y. Okay. This is actually a fine difference equation like a while ago. Okay. With A is the 1 plus the interest. Okay. B in this case
Sir,
is, yes. Can you see it? Or
sir, I think we cannot, your screen is not shared.
oh, sorry.
Thank you.
Thank you. Okay, this is the problem earlier. Can you see it now?
Yes, sir.
Yes.
Thank
And
you.
then, thank you. Mm. Okay, so if you have a 8% interest and your deposit is only 100 pesos, okay, can we get the formula? Okay, the formula is rather simple. Huh? Okay, so 1.08, this is the 1 plus the interest. Okay, and if you look at this formula, you see that this is actually a finite difference equation. Okay? With A 1.08, okay, this is 1 plus the interest, and then B is 0. Okay. So if they ask about 1 year, that means Y4 that you will get from 100 become 136. Okay. So the next question, can you develop a closed form expression into the amount of your account after n quarter or after t years? Okay, so then the formula is this. This is n quarter, and then this is years. Okay. So you don't like quarter, you put into monthly, so the 4 you change into 12, right? If you want to put it into daily, so then the 4 here you change into 365 or 360. So the same technique. Yeah. Now I want you to open an Excel for the next practice. Everyone must do this. Okay. This is very important practice because the next few practices you will start to realize something. Okay, so can you do this? Suppose you borrow Y0, say Y0 is 1,000 in here, original debt. 1,000 pesos from a credit card company. Okay, that credit card company is charging you 1% monthly interest. Okay, look at this. The real credit card is not 1%, 3.5%. Okay, so this is very, very gentle credit card company, only 1%. And you are paying 20 pesos per month. Okay, you only borrow 1,000, okay, and then you're paying 20 pesos per month. Okay, then if you look at the formula, it's just like this, right? So 1%, so 1.01. That's correct. Yeah? Because you are paying 20 pesos per month, so paying that means minus, right? So minus 20. Yeah. So this is the form. A few numbers. Okay, so one, the 1 in here is 1 month. So because you pay 20 and then have additional interest, so you get this 2, 3. This is the 3 months. So the question is simple: how many months you will off your original loan? Oh, can you do it in Excel and then put down how many months up to become 0? Okay. Everyone needs to do this. This is very important practice. Okay, I will. Okay. So
70 yet month.
70 months. That's correct. So can you plot that graph?
Plot.
Plot. Yes.
Okay.
X, Y.
Hi, sir.
Okay. Can you plot that graph X, Y? You're supposed to get like this. Right, going down from 1,000, okay, and then become 0 at around 70. Did you get the same thing? Yes or no? Okay. So the reason I asked you to make the Excel for that is so that you can simulate. What happened instead of 1,000? What happened if your original debt is 3,000 pesos? How many months you will pay off your? And what happened if your original debt is 2,000 pesos? How many months you will pay off your? And how much is actually your monthly interest charge? Any comment? Oh, show. Then you can plot, no? So 1,000 is one column. The second column is 3,000. The third column is the 2,000, and then you can plot the three of them together so that you can see what is actually happening there. Anyone? This is interesting problems.
So is it really not going to zero?
Okay, good.
I'm not plotting it yet, sir, but it's weird
Why? Why it's weird?
because it's not just, you know, reaching your debt.
Now you realize the meaning of difference equation.
You might die first before paying off the debt.
That's what the meaning of loan shark.
Sir, is it because the 20 pesos payment is less than 1% of the 3,000?
Correct.
The interest is so much big.
Okay. At 3,000 initial debt, you never be able to pay off your loan. Instead of paying off your loan, okay, the interest is getting bigger and bigger and bigger and bigger. At 2,000, what happened? What happened at 2,000? This is very
Constant value,
important
sir,
question.
2K.
Eh?
Constant value of 2K, sir.
Constant.
Constant value of 2K. When are you going to pay your debt?
No, because you're just paying off the interest.
Never. Oh. This is that 2,000 is called constant solution, fixed point, equilibrium. Okay. Shocking, yeah, initially. Yeah. Okay. Many people do not realize this. Okay. They learn the formula, right? But they don't realize the meaning of that formula. Okay. When you start to put this, then you start to realize many things. Okay. So, oh, it's possible that the payment never happened. Okay. Instead of going down, it go up. Okay. Right. So the chart is something like this, isn't it? Okay. So at 3,000, you get the green. Okay. Going up, not going down. Okay. At 1,000, yes, going down. Okay. At 2,000 is a constant solution. Okay. That means your payment is exactly the same as your interest. You never be able to pay at that point also. So you start to understand how dangerous is a debt, right? And then how dangerous it is when you are not paying your debt, actually. Because of that, the interest can go up beyond your initial debt. Okay, give me your feedback about this. What did you learn about this? At first, you don't believe that it is possible, right? So, yes, it is possible. Why? This is normal. Okay. In fact, this is what the mafia is doing, isn't it? They understand this, and then they charge you very high interest so that you not be able to pay as long as your life. Starting to understand the meaning of debt and interest. Okay, I hope you can teach this to others, yeah? Not just learn for yourself, okay? Is this important or not? What do you think? Huh? This knowledge is important, isn't it?
Yes.
So, because without this knowledge, people think that, oh, I just borrow, I will just borrow. Okay? They don't realize that, oh, if as long as I pay, it will come back, right? It will go down and then going back to zero. No, not all payment will go down. Okay? You have Excel there, you have computer there, you can calculate on your own. Okay? Sometimes you don't realize because you don't calculate. So once you calculate, you start to see, plot it. Okay? What is the direction? Okay. So, okay. In mathematically, of course, this is interesting points. Okay. It's a painful point, but it's an interesting point. The constant solution of 2000, okay, is actually called equilibrium value, fixed point. We can compute this using formula. This is very extreme important. So I put here. This constant solution is extreme important because it will tell us what actually happened in our system. Okay, so I want to generalize this not just for financial. Okay, so let's how to compute the equilibrium value, that 2000 a while ago. Okay, so we can get the equilibrium points using algebra. Yeah, how to do that? Okay, so this is your difference equation. Yk plus 1 is a function of yk minus 1, and so on, right? And then what you will do, you set this equation to be equal to your equilibrium value, which is y star. Why? Why you need to set equal to the equilibrium value? Because the meaning of equilibrium, okay, is a fixed value, right? Meaning over time it will not change. So I give you example. Okay, say our value a while ago is called affine difference equation, right? This is the formula, isn't it? Okay, so how to compute the equilibrium value? Easy, yeah. So we said, look, we write it this way: yk plus 1, okay, equal to what? Function of this one, right? So that function here is the ayk plus b, right? And then we equate this to y star. Yeah, y star is the equilibrium value. So y star equal to a times y star plus b. Yeah. So in this case, you can get the y star equal to, okay, using algebra, right? You can get b divided by 1 minus a. So get back to your earlier practice, then you can start to see how much is the equilibrium value, which is the 2000, of course, supposed to be. Yeah. Of course, in here, A must not be 0. A must not be 1. Yeah? Otherwise, you divide by 0. Okay. So another example, say, suppose you have okay, a difference equation like this, okay, which is quadratic. So then what you will do, you put this left-hand side equal to function of right-hand side. So that function is the right-hand side here, the yk square. So, and then you put that equal to y star. So this one is y star square equal to y star. And then you solve this quadratic equation, you get two equilibrium, yeah, which is y star equal 1 and y star equal 0. So why equilibrium is important is because of the stability. A system is stable or unstable, yeah? Can be stable or unstable. Say another example again here, if you want to see. Okay, say the equilibrium of this difference equation, yk plus 2 minus 3 yk plus yk minus 1 plus 18. This is the equation. Can you find the equilibrium? If you want to find the equilibrium, easy, yeah? Everything with yk plus something, you put it into y. Okay, so yk plus 2, so y. Minus 3, yk, so y again. And then yk minus 1 is y, and then plus 18 is there. Okay, and then after that, you solve algebraically, yeah? So y plus 3yk minus y. So in that case, 3yk equal 18, so y 6. Yeah? So this is the equilibrium value. Okay, up to here, is there any question about how to compute algebraically? No, yeah, it's easy, right? Just put it into the formula. Yeah? You just change everything with the subscript here into y. Okay, so next concept that I want to tell you is about stability. Okay. Mathematically, this is the definition, so that you will get the actual definition. So suppose you have a dynamical system, okay, and that dynamical system have equilibrium value y star, okay. So that equilibrium value is called stable or attracting if there is a positive number lambda or epsilon, such that when from the initial value, okay, to the equilibrium value, okay, so it will always within certain boundary. The chart a while ago, okay, if going down becomes smaller and smaller, okay, that means stable equilibrium. So that means here, regardless the choice of initial value, okay, the solution is called stable difference equation, okay, if it is temporarily perturbed. Okay, so to imagine stable equilibrium is like this. You have a bowl and you have a ball. Okay, so when you perturb this ball, say you blow, okay, the ball will go up and down and then come back again to this equilibrium value in the center of the ball, isn't it? So this means this system, the ball, is actually stable. Yeah. So perturbation will not change the equilibrium. Yeah. So we call this stable equilibrium attractor. Okay, stable equal attractor. The next equilibrium is called unstable. What is this? Unstable is also called repelling. That means when you have perturbed from equilibrium, okay, it will, when it is unstable, it will not return to the original value. Okay, so to imagine that, okay, think of the ball, you put it in the reverse direction and you put the ball there. Carefully, you put the ball on the top of the ball so that it will not fall. Okay, that equilibrium is there. So when you put carefully there exactly in the on the top of the bowl, it will not fall. So equilibrium, right? But when you have perturbation, you change a little bit. Okay, you blow the ball either to the right or to the left. Okay, it will make the ball fall from the beam. Okay, so that means this equilibrium is called repeller or unstable. Is it clear? Okay, memorize ya. When equilibrium is stable, that is also attract. When the equilibrium is unstable, that is repel. Okay. Now come back to our. Sometimes there is a neutral or semi-stable. Okay. So one direction or the other direction. One direction stable, one direction, and the other direction not stable. Possible. Yeah? So to find the stability, okay, to find the stability, you need to get the equilibrium. Okay, say this is supposed to be your difference equation. Okay, now if your equilibrium value stable, then you take the first derivative, okay, and then take the absolute value. If it is between -1 to 1, okay, that means your equilibrium is stable. If your first derivative is larger than 1 absolute value, then it is unstable. Yeah, if exactly 1, we don't know whether it's stable or unstable. Okay, so I give you an example here. So suppose this is your dynamical systems. Okay, and we compute first we compute what? We want to compute the equilibrium first, and then we compute the stability. Okay, so this is the equation. Okay, we put it into this form, right? And then every yk here become y star. Okay, so then you can, this is supposed to be y star squared. Yeah? And then you will get y, because this is quadratic, you have two equilibrium, okay, at 0 and at 2.75. Okay, so if you look at this, okay, the first derivative is 3.2, and then 2 here put down, okay, become 1.6 of x. Okay, so this is the first derivative. Okay, and if you put this first derivative, the y star to the first derivative, okay, then you can get the answer. Yeah, whether it is stable or not. Yeah, so the first one, 2.75, when you put into the first derivative here, okay, 2.75, you will get -1.2, which is unstable. Yeah, so remember, if the value is larger than 1, absolute value, yeah, larger than 1, then this is repelling. When you put 0 there, okay, it's also repelling in this case. So now back to your borrowing problem. Can you calculate the equilibrium and the stability algebraically? This is a while ago, isn't it? This is the formula. Okay. Question, whether this is repelling or attracting. What is the equilibrium value? Anyone? Please try. I will stop us. All right. So if you put that in the form, right, you get this format. Okay, and then if you want to calculate the equilibrium, of course, you put this yk equal to y star, okay, so that, and then you equate that the same as y star, from here, you just algebraically put there in the right other side. So you get 2000. Okay. And then from there, okay, the first derivative is 1.01, which is greater than 1. Okay, so that means repelling. You can see here from the graph also, okay, 2000 here. And okay, let's try. You have an Excel, right? So instead of 2000, can you change that to 2000 and 00001? What is the graph, going up or going down? And then the same, instead of 2000, you change that. Instead of 1000 here, you change into 1999. Still going down or going up? So that you will see the meaning of perturbation. Okay, small change from the equilibrium, okay, it will eventually have the same graph as this one over time. Okay, that means this is repelling.
Can I share screen, sir?
Oh, sure, sure. Go. Yes.
Sir, no plot yet, but I can see the trend, sir. When
Yes.
it's 1999, it's going down.
Mm-hmm.
While when it's 2001, sir, it's going up.
Going up. Yeah.
Yes, sir.
Okay. Even very small perturbation change, it will change from the equilibrium. Yeah. Repelling. Yeah. If going a little bit up from the equilibrium, going up. Okay. A little bit down from the equilibrium, going down. Yeah. Very good. Yeah. Okay. So this is a interesting system. Okay. So not only financially, you can start to see if you find anything, okay, and you can put into the differential equation, then you start to check. Okay. Now, three things actually. Number one, you find the solution, of course. Number two, you need to find the equilibrium. Number three, you need to find the stability of the system. Okay. Repelling or attracting. Okay. I don't want to go further than this, but if you want to find more detail about this, you can go to my YouTube channel. Get a lot of talk deeper than this one. Yeah, much deeper than this one. So we can go to autonomous things and so on. Okay. Anyway, so at this point, we can just stop here. Okay, let's go back to the financial matter. So we have what is called concept of equivalent. Okay, so this is a new thing. Huh? When you have two cash flow, okay, now we must compare their characteristic based on the same basis, isn't it? So you have two cash flow equivalent at interest K, okay, and then if we can convert that cash flow into another using the proper compound interest, the six formula a while ago. Yeah. Say for example, yeah, if you have 10,000 deposit for 3 years at 8% interest, okay, that will accumulate become 12,597, isn't it? Okay, so that means at 8% interest, okay, now this is the most important part. Okay, at 8% interest, that 10,000 that you deposit at time zero is equivalent to the 12,597 at time 3. Do you understand the meaning of equivalent in this case? Okay. the money that you put today, 10,000, and then say that interest is 8%, put it fixed. 3 years later become 12,597, right? That money is the same money. Okay. Okay. Suppose you need to take 1 million loan to buy your house. Okay, the interest rate is 10%. Now you have three options, 5, 10, or 15 years. Then the question is simple. How much is your actual total loan equivalent that you need to pay for each option? Can you calculate that?
So at 1 million, sir,
Mhm. So you get 1.6,
at year
2.5,
5, yes,
and then 4.1.
4.1.
Excellent, excellent, excellent. Yeah. So at 10% interest, okay. So okay. So at 10% interest, if you have 5 years, you will get 1.6 million. Okay. 10 years, 2.56 up 2.59, and then 15 years, 4.18, approximately. Yeah. So that means they are equivalent. These four numbers are actually equivalent, the same. Okay. They are only different in time and different based on certain interest rate. Okay. Now, in economic evaluation, okay, usually we have what is called cost and benefit, isn't it? Okay. So let's go back here. What are the costs, right? Say in many transport projects, usually these are the costs, the capital, the construction costs, and then you have the operation costs, and then you have the repair and maintenance costs. There are also administrative and taxes. These are the usual costs. And next, for the benefit or the gain, okay, you probably gain from the income, okay, from the rent, sales, or you can get from the subsidy when you finish the things, say your equipment, you sell it back, you get salvage value. Okay. Sometimes you can get the increase of your property value, okay, or your land, your IP, and so on. So these are the benefit. Okay. Now, given the equivalent concept a while ago, okay, you're supposed to be able to compare, okay, uh, by getting the cost and the benefit, and then you put back all into the equivalent with this, for example, present value. Okay, everything you compute into present value. And then with that, you can start to evaluate your project. Okay, these are the several indicators that we usually use in economic evaluation of an investment. Okay, so one is called NPV, or net present value. Formula is simple. You compute all the benefits, and then you compute all the costs, okay? And then you take the minus. Okay, the same thing. Yeah? You can also get second economic indicator is called PCR, or benefit cost ratio. Again, you compute all the total benefit and then you divide. Yeah? Instead of minus, you now divide. Of course, NPV, yeah, must be larger than zero, isn't it? To make the total benefit larger than the cost. Okay? BCR, in this case, must be larger than 1, so that the total benefit is larger than the cost. Okay? And another economic indicator is called IRR, or internal rate of return. Okay? This is basically the interest rate of your project. Okay? Of course, now you compare. Okay? This IRR, interest rate of your project, compared to, for example, the bank loan. Okay, so say you are business, you want to do business, right? So what you will do, you compute the cash flow of your business, you project it. Okay, if your IRR of your business is larger than the bank rate of you borrow, that means your business will earn more than the one that you borrow. If the IRR of your business is actually lower than the bank rate that you borrow, then don't do, of course, right? Okay. Another evaluation indicator is doubling time. So, but having this simple formula is not enough. Okay, why? Because some projects have longer than the others, right? And then they may have a different interest rate over years. In that case, you cannot compare chicken and duck. You must compare chicken with chicken, isn't it? So in that case, you need to compute them at the same equivalent cash flow. For example, you put them everything in present year. Okay. Oh, then you will ask, can I put that not in present year, but in the future year? Oh yeah, okay, no problem. In any year that you want. Can I put that not in the present year, not in the future year, but in annuity? Yeah, of course, you can also do that. Okay, so anything, as long as when you want to compare, you compare at the same value, the same equivalent. Okay, so in my case, easier if you put everything in the present year, at the year zero. Okay. After that, you can use any of this indicator to compare various investment. Sometimes the rank of this indicator between one project and the others is not the same. Okay? So that also need to be considered. So NPV, okay? NPV is an indicator, say you convert all the benefit, okay, to the year zero. Okay? And then all the costs to the year zero. Okay? And then you compute SPV. So again, if NPV is positive, then the project benefit more than the cost. Okay? Then the project is feasible. PCR, the same thing. Okay, you need to convert the benefit to the year zero. Okay, or all the costs also to the year zero, and then you define. Okay, without that, you will get a different comparison. So you need to put in the same year, okay, equivalently, okay, all the benefit and the costs. Okay, how to say that the PCR value is good, feasible, must be bigger than 1. Why? Because meaning the benefit is more than the cost, isn't it? Yeah. IRR, the same. Yeah. So to compute IRR, we convert all the costs and the benefit of any years again to the equivalent basis. For example, the present year or the annual or the future year. Okay. So what is IRR? IRR, okay, you make so that the sum of the benefit equal to the sum of the cost. Okay, benefit zero and the cost zero, and then we compute what is the bank rate. Okay, now once you get the IRR, okay, we compare the IRR with the bank interest rate plus the inflation rate. Okay, so if the IRR is higher than the bank interest plus the inflation, then your project is feasible, right? So any question up to here? Okay, let's practice. Maybe with the practice you will get better question. So say you have two possibilities. I guess I'm just selling a software. So uh, in the first 2 years, okay, this is the interest rate. Okay, and then you pay in the first 2 years you pay 20,000, and then in the year two up to five, 2, 3, 4, 5. Okay, this is the interest rate, and then you will get 15,000. Okay, what is? Do you want to do this or not? That's the question. Yeah. Okay, if you have this is the cash flow that you have. So the technique is simple. You convert everything to the year zero, and then you compute the PCR and VPN. Do you want to do this so that we can get the better understanding?
Yeah, I just have a question. For the benefit cost ratio, the
Mhm.
summation of the benefits and the summation of cost, are they present value cash flows?
Correct.
I
P0.
think yes.
Okay. So you need to convert everything into the year zero, yeah, present value. Okay. So
Sir, can you flash the given again?
my screen again. Okay. So so I think this is interesting. Anyone want to share your screen to conclude?
Sir, is it okay to try?
Oh, sure.
Let's try, sir.
That's right. But
Here, sir.
okay.
So,
Better if you put it into a table of year 0, 1, 2, 3, 4, 5.
so
Okay.
I just played with the formula of interest a while ago. So I can use
Okay.
the present value. Here's the
Because
formula, sir.
meaning first year you get 20,000. You need to pay 20,000. The second year also you need to pay 20,000.
Okay,
Okay,
sir.
so that means 20,000 each and then 15,000 each from year 2 to 5.
Correct, correct. Every year in
Okay,
year 2,
you
3,
get
4, 5,
okay.
you get
Okay,
okay.
sir.
Thank
Thank you, sir.
you.
Okay, okay. Yes, Aaron.
Sir, I'll try also.
Okay, okay.
Sir, can you give me permission to share?
Why? You're not. Yeah, already. Oh, I guess. Um, okay. Why I cannot put you? Do you have 2 or 1? Okay, let me check again. Why I can only pin you? There. Hmm? What?
Is someone trying already, sir?
I have no idea why I cannot put Aaron as co-host. Sorry, Aaron, I cannot put you as co-host. I don't know why. Are you using certain system that?
Let me try to exit first. Not sure how.
Okay, maybe someone else want to share screen.
Prof, I think Angelo is the host. That's why.
Eh, why? There is no. Okay, not me, the host. That's why. Okay, Angelo, can you put me as co-host or host?
Please try again, sir.
Can you put me as a host? And then can you put Aaron as co-host? Angelo, in the participants, can you put that?
Uh,
This is funny technical issue. Anyway, any of you are co-host, so you can also take that actions.
there, sir.
Sir, I think I can already share my screen. Hold on.
Okay.
So for this one, so the benefits are from years 2 to 5, so that's 15,000 from years 2 to 5. Then I get the cost of 20,000 for years 1 to 2, so that's negative 20,000. And then I get the net for all years, so negative 20,000.
No, no. You need to put that into NPV first.
Okay, hold on, sir.
In row 7, you need to get okay, the net per year, that's fine. So and
Right.
then
And then I
Okay.
get a discount rate of 1.5% for the first 2 years and 1.75% for 3 to 5. Then I
And
get the
then
discounted cash flow for all the 5 years. Then
per year.
per year, sir. And then the sum of all those five is the net present value.
Uh, yes. And then the BCR.
The BCR is the sum of the benefit, which is this discounted value, these three, divided by the sum of these two. So because these are the costs.
Okay. So
And
it's
right,
better if you put separate. Yeah.
right,
Anyway, look at the same thing, but it's better if you put this the benefit into present values, and then its cost you put into present values, and then this net that you put a while ago is
yes,
already in the present values because you put this in each year, right? The net,
right.
right? So it's better if you put it in the present value everything, and
First,
then you
okay, got it, sir.
okay, got it.
So
So
it's
IRR is okay. Probably
the
will get all.
yeah,
Yeah, the IRR you get from you can get everything from there, right?
you're right,
And
sir.
oh, this is 21%, the IRR.
Yes, so sure for the IRR, I just got the IRR of the discounted cash flows.
Supposed to be all of this, right?
Right.
T until it, that's correct. Okay, that's correct. So the benefits cost ratio, the cost you put it as positive so that you can get the see now the problem happened.
Right.
Because it's simply because you did not separate the cost and the benefit.
Okay,
Anyway,
got it, sir.
that's okay. That's okay. Just if you put it separate, then you can start to put this is minus rather than positive. Yes. Yes, Angelo.
Can I try, sir?
Yeah, sure, sure. Oh, different part. Okay. The
So,
cost is the oh, you put that before this, can you put everything into present values? PV. So PV of the cost, PV of the benefit. Okay, so you can one more in E and F. Can you make two columns of PV of the cost, PV of the benefit? Yeah. Insert these two columns.
this one, sir.
No, you don't need to sum that. This sum does not mean anything because they are in different years, so you cannot sum. Mhm. So insert two columns, yes, in E and F. Insert, okay, and then that PV of the cost, okay, and then PV of uh, the present value. So if you know the future, can you get the present value? If you know the future value, can you get the present value? Okay, back to the formula in page 94. Can you go down to the page 94 in the formula? So if you know the future at the second row, can you get the present value? That means use minus PV of K and 0F.
Minus
Minus PV, PV, that is a function formula. P, correct, and the rate is that. Oh, Oh, the rate is also changing. Okay, anyway, so it, okay, the N and then 0 and then F is
Zero.
okay. You move that to the second, to row 4, so that okay. Then copy to row 5, but when you copy, be careful because your interest does not go to the same place. Hmm? Why the cost changing become 2004? This cost that's supposed to be 20,000. Ah, you already put is already in PV. So let's put that 20,000. Okay. Ah, okay. That's 15,000. Okay. Now the PV of the benefit. But the interest is different, right? And then, okay. T1 is that right? Yeah, the K is T1, right? Okay. So that now you can sum that one. Sorry, a while ago, apparently your sum is already correct because you are already okay. So you can get the sum at the bottom of E and F. Column E and column F, you can. Okay, that. So the NPV is just E minus F positive. Okay. And then the PCR is again the F minus so 1.4. Okay. So the same as Angelo while ago, isn't it? The same? Okay. Very good, very good. So anyone want to share screen again? Thank you. Katrina. Oh, can we make it larger? Okay, that's the inflow, the interest.
These are the years, and then I
Okay.
input per year. And then these are the PV for each year. And then the benefit is the sum of the present value of the benefits, and the cost is the sum of these two. The MPV is the difference, BCR is the quotient.
Then can you calculate the IRR?
Sir, how to calculate the IRR? Sorry.
Minus equal IRR, and then you need to get everything in the sum of the total of the PV. Okay. So if cost must be negative, its gain must be positive. So you did not have that yet.
Not yet, sir.
Hmm.
Sorry. So for the present cost of the benefit, the present benefit and present cost. So basically the difference of the two.
Correct. But in the present form, and then after that you put all in one array. It's not that. It's not the NPV.
Okay.
You need to get all the array. I think a while ago, Mr. Angelo already did.
Okay.
Angelo, can you show again?
Okay.
Or Aaron, a while ago.
So
Yeah,
uh,
that one.
to minus the benefit minus the cost for each year.
Right.
In the formula, you just type IRR then
Correct.
the columns.
So to get IRR correctly, you should have a positive and minus. Okay. If only positive will not work. Only minus will not work also. Okay.
Sir, in
Yeah.
the computation of the IRR, since uh, is it okay to put the guess percentage like the social discount rate given by the NEDA?
Yeah, sure. So in IRR, okay, usually you need to put the guess rate first.
That's the
Okay.
rate
Yes.
for net is
10%.
Oh,
10%.
yes. The question is why, right? So when you put the guess rate, okay, it will search around that area in the computation. Okay, because sometimes the IRR can have several results. Okay, and if you don't put the guess rate, it will depends on the computation. It depends on the initial value. It can go to other uh, equilibrium. Okay, which is far from the actual one. So when you put the guess rate, it will go nearer to that rate.
Sir, can I ask a question?
Oh.
Why do we apply sensitivity analysis?
Oh, why?
Yes, sir.
Why do you apply? Okay, so we have the slide on sensitivity analysis next time, but at this point I will answer it. So if you change the interest rate, for example, okay, because you put the interest rate, for example, 10%. Okay, in reality, it doesn't happen to be just 10%, right? Because the interest rate can change over time. Okay, so when you try to get the sensitivity, okay, then you start to see how sensitive it is for each factor that you put there. Okay, and you want to know first which factor is actually the most sensitive to the change. For example, there is some fluctuation in the interest rate. Okay, then you want to know, is this really still feasible or not, right? So probably because the change of the interest rate will change the whole feasibility study. Okay, then you want to know whether it is true or not. Okay. So at certain points, you can start to see, oh, this is the problem of the interest rate. So you can also check the sensitivity of other factors. No? Okay. For example, the time of the year, maybe the cost. Okay, each factor you can calculate that analysis. And then you want to know which factor actually has the most sensitive. Okay. Based on that, then you start to see, oh, in this case, because this is the most sensitive, that means small change, small perturbation, okay, in that factor will affect the greatest impact in the feasibility study. In that case, you need to better care about this factor, isn't it? Right? So by computing sensitivity, okay, you will get a lot of insight. Okay. Sometimes instead of sensitivity, we also compute what is called elasticity in economy. Okay. Anyway, there's a time we will discuss about this more detail. Okay. And with that, you can start to see. Okay. Aaron, you want to first, Angelo, did I answer your question or not?
Yes, sir.
Okay. Thank you. Thank you. Aaron, please.
Sir, just to clarify, for the computation of the IRR, the numerator should be not the present value, right? It's the 20,000 and the 15,000.
No, should be in the present values.
Okay.
Everything must be in both, three of them, yeah. PCR, NPV, IRR. Everything must be in present value.
Okay, sir. Got it.
Okay. So, but be careful. The notion that I said must be in present value can be arguable. That means if you don't like present value, okay, I can change that into annuity. I can change that into future value of certain year. That is total the same thing because they are equivalent. So there is no problem with that.
Right.
Okay. But the easiest is, okay, let's compute everything in present value.
Okay, sir.
Okay. Okay. Anything else?
Sir, is there any decision rule like in our department where we have this decision rule? For example, that this social discount rate given by NEDA is 10%. So the
Mhm.
decision rule is actually
Larger than that.
I'll just share my screen. Can
Okay.
I just share my screen?
Sure.
Yeah. Are you able to see my screen, sir?
Yeah. So,
Yeah. So the decision rule, there are different decision rule for like for NPV we have
yeah.
NPV is greater than zero, accept the project,
Right.
reject if it's less than zero, and equal to zero may be considered. And then for benefit cost ratio, whenever well, obviously if the benefit cost ratio is greater than one, accept the project, less than one, and then equal to one. And
Uh,
then IRR also. EIR.
That decision rule I mentioned a while ago. Okay. This is not accept. This is just feasible.
Okay. It's just feasible, not necessarily accept.
Yes,
Okay.
because so that decision rule is probably still incorrect. Huh?
Okay,
So
sir.
this is only accepted, not accepted as feasible only. Okay.
Okay, sir.
Of course, you will have several alternative A, B, C, for example. Okay, the three of them
Mm-mm.
are feasible,
Mm-mm.
right? The three of them are feasible, isn't it? For example,
Yes.
alternative A is feasible, PCR larger than 1. Okay, alternative B also feasible, PCR also larger than 1. Okay, and the same thing that C. But which one is the one that you run as number 1?
Mm.
Is it based on PCR, that largest PCR, or is it largest NPV, or
Oh, okay.
largest? And that's more difficult question, right? Because
Okay, sir.
larger than 1, larger than 0, that is only feasible. Okay, not
Mm-mm.
necessarily chosen. Correct, yeah?
Yes.
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 So,
Thank you, sir.
yeah, thank you, Raisa. So, I put that a while ago in the screen. Where is that? There, right? So, this is the decision rule that a while ago Resi was mentioning, right? So, if the value of NPV is positive, okay, that is feasible. That means if the NPV is negative or 0, they are not feasible. Okay. The same thing with PCR. Okay, if PCR value is larger than 1, then the project is feasible. Feasible only, okay, not necessarily optimum, right? Okay, and IRR is the same thing. Yeah. Okay, so we compare. How do you say the IRR is feasible? Okay, so I put here the IRR you compare with the bank interest rate plus the inflation rate, right? If the IRR of the project is higher than the bank interest plus the interest rate, then your project is feasible. Feasible does not mean that this is optimum. So at the minimum, this is called feasible. Okay, and if you have several projects they are feasible, then you need to find the optimum. Okay, that's another question, right? So when we do, actually we already learned about how to optimize. No? Last time we learned about knapsack and so on. That is how you optimize, isn't it? Okay. But at this point, we are talking about feasibility only. Can you see the difference between feasibility and optimum? Okay. When you want to do optimum things, the one that you optimize are the feasible projects. Okay. If they are not feasible, don't put into the consideration. Okay. I hope this is clear. Is there any other question probably or discussion that say? So you learn a lot about this, yeah, in other courses and also in your work. I believe you already learned a lot about this. So in the rest of this slide is rather simple. You see, if you look at the slide next time, okay, these are just the derivation about each of the formula. Okay, so if you have a P is your present value, F is your future, and K is your interest rate, and N is your total number of years. Okay, of course, you can get in 1 year you get this, in 2 years you get this, huh? And then in N years you get this formula. So sometimes it's easier if you put the cash flow like this, with this kind of drawing. Okay, down mean you pay, up mean you get money. Okay, so using this, you can do this practice very easy. No? So assuming that your say 5% compound interest, and today you have 700 something. Okay, how much is the money worth equivalently in 5 years? Of course, you just put into the formula, and you get 1,000. Okay, so to compute the inflation, suppose you spend around 100 pesos in each meal in cafeteria, and the government said the inflation rate is 5.5 per year. Okay, so based on that information, how much is the price of the same meal 5 years from now? Okay. So put that into the same formula, you will get 130. Right. Okay, 130 pesos 5 years. So that is the first formula. The second formula is to get the present value, which is the same thing. Okay, if you know the future, okay, how to get the present value? You just put back the formula a while ago here. Okay, now you want to get the present, so this term here, it is 1 plus k exponent n, you put down there. Okay, then you get the present value from the future. So this one. So the practice is so again the same thing. Yeah. So suppose you get 1,000 a year from now. Okay, assuming 5% return, how much is the present value of that? So the point is the present value, okay, is always worth less today, okay, than the same amount that offer immediately. So the sum of 1,000 offered to the person a year from now is worth less than today than the same amount offered immediately. Okay, So if 1 year from now is 1,000, that means the present value must be around. So now, if you know the present value and the future value, can I get the interest rate? Yes, of course, right? The formula is rather simple. So I know the future value and the present value, and I know the time n. Okay, so using this, you can calculate the interest rate. Okay, so can you compute the inflation from here? A while ago, okay, using this interest rate, no? So Abi was saying that the jeepney fare in 2005 was 4 pesos, and today 2024 is 12 pesos. So the minimum fare. Well, what is the interest? What is the inflation rate? Interest rate is the inflation rate, the same thing. So 2024 minus 2005. How many years? 19 years? So N is 19, okay? F is 12, and then P is 4. Oh, what is K?
Sir, is it 5.95%?
Maybe. So
Wait.
that means huh? I did not calculate. So this is based on your data. So I'm just asking how much. You want to share your computation so that everyone can see?
Wait, sir, I'm not sure if it's correct.
I mean, it's interesting to see. I mean, the actual inflation in transportation in jeepney alone, 12 divided by 4. Okay, so you get how much? Yeah, that's correct. Okay, 5. You can put that into percentage. Okay, almost 6%.
Yeah.
Okay, so when the government said 3 point, how much? 3.8, probably this year. Okay? But in the past 19 years, every year you get that inflation rate. Wow, actually much bigger. Very sad reality. Oh, with that, you can get any inflation rate. Okay. Oh, how about return? No, okay, the inflation is negative. So how about return? Okay, so say if you have, say, suppose you get, say you put money, 5,000 pesos, okay, to buy, say, Bitcoin or something. Okay, okay, say, and then in 10 years, okay, become 160 dollars. So 5,000 is the same as $100, right? So in 10 years, say become $160. So what is the annual return per year? Okay, so can you calculate? Easy. How many percent? Hmm? Yeah, 4.81. That's correct. Yes. Okay, so when we put into Excel, okay, this is the formula a while ago. Yeah, so you get 4.81. But this is what is wrong. Okay, so that you will see. Many people they just think this way. Okay, 160 minus 100 divided by 100, and then you divide by 10, you will get 6%. Okay, but it's not true. This is over. Okay, so it's only 4% per annum. Okay, oh, and then okay, this is the same. I came to Philippines 2008. The food in cafeteria was 45 pesos. Okay, and I took the meal in 2012 and it was 65. Okay, and then in 2018 was 100 already. The same food. So, what is the actual inflation rate? Okay, is the inflation rate between 2008 to 2012 the same as inflation rate from 2012 to 2018? Okay. Can you stop the computer? So all you need to do is to compute the number of years, okay, and the value, yeah, 65 and 45. This one is 100 and then 65. Okay. So between 2008 and 2012, okay, is 4 years, so I get 9%. Okay. And between 2012 and 2018 is actually 7%. Okay, so that means the inflation is reduced. Earlier was even worse in that case. Yeah? But if you put 2008 to 2018, that is like 8% on average. This is the inflation, real food. Same place, same food. Okay. So always the case that the real inflation in terms of transportation and food is much higher than what the government is reporting. Okay? They always put the inflation rate very small, okay? Maybe 3% to 5%, but in reality, it's much higher. Okay, so what's the effect of inflation is actually decrease of value. Yeah? So suppose you have $10,000 today, okay? Okay, at 5% inflation rate, okay, what will be the equivalent value of your money 10 years later? Okay, how much reduction actually to compare to the original value? Can anyone compute this? So in this case, the inflation rate is given, okay, 5%. You also know the present value, P, 10,000. What was asking is the future, isn't it? So then you just use the future value, knowing the present and the interest rate and the number of years. So, okay, 10,000 today, okay, that is equivalent to only 6,000, yeah, almost 6,000 10 years later. Yeah? So the total reduction is about 40%. Yeah? Annually 5%, but in 10 years, okay, it's actually reduced to 40%. 40%. Okay, so your money worth less because of inflation. Okay. So at 5% in inflation, okay, your money worth less 40%, okay, in 10 years. That's the meaning of inflation. I hope this is useful for you. So, is there any question so far of this? So, next is called Rule 72, okay, doubling time. So, if you want to know, okay, how many years required of your money to double given your interest rate, okay, and you don't have calculator, you are actually in the field, do not have any gadget, okay, then you can compute easily using Rule 72. Okay? This is approximation. Okay, so well-known Rule 72, meaning that the number of years required for the money to double at certain interest K equal to 72 divided by that interest rate. Yeah? For example, say at 6%, okay, your money will double at 12 years. Okay. Then you ask, okay, I don't want approximation, I want the actual value. Okay, I want to get the actual value. Okay, if you want to get the actual value, this is the formula, quite complex, yeah, using log. Okay, so if you like to know how long, how many years you need to wait to get a certain amount in the future, right? So you know F, F means the future, P is the present time, and you know the interest rate. Of course, now you can get the N, yeah? Okay, using this formula. Yeah, you can derive this easily, no, from the earlier formula. So let's use this in the example. Okay. Suppose you have 1,000 pesos today, and then you put in a cooperative, okay, that give you 10% dividend per year. Okay. Now, question is how long you should wait your money to reach 2,000 double. So in that case, you just put into Excel. Okay, so the present value is 1,000. The future value is 2,000. Okay, K is 10%, so 0.1. Okay, and if you compute this, you will get 7.2, which is approximately the same as Rule 72, isn't it? Okay, so the Rule 72 work pretty well. Yeah. So in this next practice, I'm trying to investigate, okay, when is the Rule 72, okay, have a big error. Okay, so in that case, we put the interest rate from 1 to 35%, okay, and then you compute the doubling time. Yeah. So what is at what interest rate Rule 72 will have more than 0.5% absolute error. Yeah. So we put that into Excel. Okay. So this is the exact period of doubling time based on the earlier formula, this one with the loan. Okay, and then this is the Rule 72. Yeah, and this under approximate error. You start to see that for K less than 3.5, okay, if K less than 3.5, the error is actually larger than 0.5. So for big one, the error is pretty small, pretty okay. In fact, if the k is small, the doubling time of rule 72 is not that accurate. Okay. So in what scenario you think doubling time is important for you?
Population forecast.
Maybe population forecast. Okay. So if you want to do, say, any investment, ROA. Yeah. So if you want to do any investment, the doubling time can be a good indicator, right? So how long, okay, based on this investment, how long it will double my asset. Okay. So if you want to compare business, okay, say, have you ever tried to compare any business? Can I give you that as your assignment? Okay. For example, you can compare condo unit. Okay. If you own a transport like taxi business, for example. Okay. And a personal project, no problem. Okay. So that you can see comparison between at least three possible investment. Suppose, now imagine that you have say 10 million pesos. Okay. So and then you try to get at least three investment possibility, and then can you calculate the benefit and the cost, okay, operation, okay, and so on, and then you compare what is the PCR, IRR, okay, NPV, and then doubling time, and of course the ROI. I think that is an interesting assignment. Okay. Imagine you have 10 million pesos, and then what can, it's up to you. You can select any, and then based on that, can you tell me, okay, which one is the best? And you can start to see. I computed with the real value. For example, in condo unit, I think it's around 5%. Okay, IRR, right? Probably taxi is the best. No, the doubling time is only 2 years. Okay. That my computation a long time ago in 2000 something. Okay, so but you can try on your own using current situation of your price. I think this is very interesting. At least three investment project, personal. Is that okay? Put it in Excel and then you can. Okay. So up to here first, and then we can continue next week about all these many things. Okay. Thank you for today.
Thank you, sir.
Thank you,
Thank you,
bro.
Prof.
I hope this is interesting.